Okay, we're up. Ready? All right. So Dmitri Mendeleev, this guy, he's the guy that came up with the first periodic table. Okay, so there was a time when a bunch of people were like discovering atoms and stuff like that, and
On my definition, it just says scientists that noticed the periodic table of elements when they were arranged by atomic mass. It doesn't say anything about him coming up with it.
yes, he was the first person, and I just made a note card on that, and it might be like right after that, and it just wasn't refreshed in your end. But it's okay, I added it. You can copy it down later.
I should say first person to make.
Well, I have it here. You can see it. Here, pause. Okay, so think about like a clock. Okay, so like you have 12 o'clock, and then 1 o'clock, and 3 o'clock, and 6 o'clock, and 9 o'clock. And let's say that at every
Hour?
what could I say? You could say every, yeah. So like let's say you have 0 minutes, right? And then you have like 59 minutes, I guess. And then you have like these 15-minute intervals. So that's 15, and that's 30, and that's 45. That's kind of like 60 over there. And this would be like 1 p.m. And then 2 p.m. you have the same thing, right? You get your 0 minutes, and then your 15, your 30, your 45, and let's just say that you had some sort of crazy disorder where at every 15 minutes you had a seizure, okay? And then at every 30 minutes you had a heart attack. And then at every 45 minutes, I don't know, what's something that bad? You could have a stroke, okay? Somehow you survived all of these. And then at every 59 minutes, you just burst out laughing. You with me? But then it happened again at 2 o'clock, and then again at 3 o'clock, right? So can you explain to me what this scenario is?
It's a pattern.
Pattern. And is it a predictable pattern?
A what?
A predictable pattern?
No.
It's not. So I can't predict when you're going to have a seizure.
Oh, well, yeah, I guess.
When are you going to have a seizure?
At 15.
Are you going to have a seizure at 4:15?
No.
Sure you are.
Oh, yeah, 4:15.
Right? Are you going to just burst out in laughter at 2:59?
No.
Yeah.
Oh, wait, yeah.
This is the laughter one. So laughter. Right? And what was this one? I think it was a heart attack. Are you going to have a heart attack at 5:30? What's going to happen at 7:59?
Laughter.
Right. What's going to happen at 8:15? The first horrible one.
Heart attack?
Seizure.
Seizure.
I don't know how to spell seizure. I think it's like that. Seizure. So what he realized was there's certain elements that do kind of the same thing. He found like a pattern in the periodic table, right? And he was like, hey, all these elements that are kind of like this. Oh, hold on. Okay, ready?
Ready.
Okay, so this pattern, this repeating pattern is called periodic. Okay, and he said, hey, even like you have elements that he kind of just figured out that just like these are like the hours. He's like, you can go down these like levels right here, right? But if you're all the way over here on this column over here, all of these elements on the periodic table. So like if this is really the periodic table, I'm talking about like all of these over here. These are all kind of doing the same thing. And all the ones over here on the periodic table, those are all they kind of react all the same way, right? So he just had a bunch of like index cards basically, and he started just moving them around. And the ones that actually behave the same, he did that, right? So he built the periodic table by, but he built the periodic table by just organizing the elements according to how similar they are in the way they respond. So what did Mendeleev do?
He built the periodic table organizing the elements by how they correspond.
Good. And that repeating pattern is called what?
Periodic.
Good. And the one thing that's actually super cool, take home message, fun fact at the dinner table tonight, is when he did that, when he made his periodic table, he had holes in it for elements that
That
have not.
haven't been discovered yet.
Yeah, that's pretty cool. Like there's an Einsteinanium and a Californianium and a francium and a Steve Lozanoianium, and my favorite, the one named after Jermaine Jackson, germanium. So yeah, that's kind of cool. All right, that's our homie Mendeleev. So Mendeleev isn't also the person. He isn't just the person who did the periodic table. He's also credited for being the discoverer of the periodic law, which basically just means the elements behave periodically, just like my silly example here with the heart attacks and strokes and stuff. How that's
Okay,
periodic.
This one for Dmitri or whatever.
Yeah, and I was going to put it down right now. All right, so there is a guy. I forgot to put his name in the thing, but his name is Cannizzaro. Cannizzaro, who might not be in the test, but maybe. Cannizzaro.
If he's on the homework, he'll probably be on the test.
No, because your teacher doesn't write the test.
Yeah, but the test is the homework is from the textbook.
Okay, Cannizzaro, what he realized is he's the guy that has to do with atomic masses, relative atomic masses. Okay, so he organized elements according to their mass. Okay, but he didn't notice that there was like a repeating pattern. So he just like, you could think of his table as just being like a line, like this one's bigger than this one's bigger than that one, this one's bigger than that one, like that. All right, so if the question says like relative atomic mass, it's that guy. The person who noticed that there's like a periodic nature to elements would be who?
Moseley.
The person who noticed this concept right here. Mendeleev. He noticed that things repeat, right? But there's something that Mendeleev couldn't figure out. He couldn't figure out when he did this, he didn't actually understand why. Like if you look at the time, like this is 59 and this is back to 0. This is like, if you think of it in terms of like mass, that would be mass 59, and that'd be like mass 60, 61, 62, 63, or like more like 75, 90. He thought that this should go over here. He just noticed things repeat, but he didn't really understand, like, the next highest number is 60. So 60 should be just like this one, because he noticed he did notice that like there's similarities here. These guys are kind of all similar, but he didn't notice why this one. He didn't know why this one was so drastically different than that one. He didn't know, like, on the periodic table. This is Dmitri we're talking about, Mendeleev. He didn't know why, like, this element was so different than this element. Like the one, like, that's right after it. Like its atomic number would be right after it. Like you would think it'd be like similar to it, but it was completely different because the ones that are similar are the ones that are going down this line. Does that make sense? All right, and then because he was like, all right, if you look at like aluminum on the periodic table, so let's say aluminum is right here. Aluminum. So what's aluminum's mass? 26.98. Okay, so is it going to be kind of similar to this one?
Yeah.
It'll be similar to silicon. And look, if you look at silicon, silicon is 28.0855. You see, so doesn't it make sense to list them by increasing atomic mass? Like you can do that because that, like, this one is similar to this one, and this one over here is similar to the one that has a mass of 30, right? But there's a problem. The problem is if you look at iodine and this one, what's the mass there?
127.
What's the mass there?
126.
But it's supposed to be small, big, bigger, 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 bigger. But then over here, big, small, big, right? And Moseley comes along and says, guys, it's better to arrange them by atomic number than atomic mass. Atomic number, so Moseley, what's atomic number, by the way?
The thing above that element.
So atomic. So you have like your mass right here, right? And the number is the one right here. That's your atomic number. And Moseley said, it's better to arrange them by atomic number. And if you arrange them by atomic number, which one goes first? Tellurium or iodine? Tellurium. Even though it's not correctly in increasing mass order, because Dmitri thought it was an increasing mass order. Okay, so, but then his explanation couldn't explain certain differences. So Moseley said, hey, put them in an order of increasing what?
Atomic number.
Yeah, increasing atomic number. But who's the first person that just says, hey, there's a repeating pattern? Yeah, Mendeleev. Yeah. So then there's another guy. The other guy is the guy that discovered that there are certain elements that didn't react. Like there's non-reactive. Like everything is pretty much like you can make like bonds and things can like cause certain things to fizzle and stuff. But there's certain ones that just don't do anything. So those are the noble gases.
Yeah.
So Sir William Ramsay, he's the one that discovered noble gases. Ramsay. What did he discover?
Noble gases.
That's really the question that would be on the test. What did he discover?
So I should copy more.
Yeah, I put him down. Okay, so then, what was I going to say? Oh, and so he's responsible for group 18. Because before they just ended it at group 17 or something like that. So, noble gases, which is group 18. All right, pause.